Howdy. Welcome to graphing a linear absolute value function. When we're talking about a linear absolute value function, we're talking about a line, drawing lines that look like a V for an absolute value. With every video, if you miss information, you can slow it down using your settings, rewind it, or even restart the video to watch it again later, or to watch it again. That's a reminder. I may go fast, but you can always slow it down and re-listen. First thing I want you to look at is the assignment. So if you're doing this on Khan Academy, and etc., you can watch that video, or you can use this video as well. But the first thing I want you to do, go to the assignment and open up Desmos, because we're going to graph starting right away. Then we're going to do the notes after. All right, I'm going to blow this up so we can see this better. I want you looking at this one right here. We're going to graph y equals negative absolute value of x plus 1. In order to do that, we need Desmos right here. So I'm going to type this onto Desmos, but first I need to type the parent graph. So I go here, y equals absolute value of x. Done. That is the parent graph right there. All other graphs will be compared to this one. So this is my boss. All the other ones will be changed in some way. For example, this first one, y equals negative absolute value x plus 1. Okay. I can see one obvious difference is it's not facing up anymore, it is facing down. So I'll come over here. It's facing down. The vertex. The vertex is, if you, everyone hold your fingers, this V, the vertex is right there. So the vertex is the bottom of the V, or if it's facing down, it's the top of the V. Your vertex right there, the V. This is my vertex. Negative 1, 0. Okay. Vertex, negative 1, 0. That's out. Does it have a maximum or a minimum? Well, that is a maximum point because it's the highest point. Circle it. Maximum point is 0. As high as it goes is 0. Everything below it, it goes from 0 down. Is it narrower, wider, or the same as the original? Well, look at this, these two. I'm going to say it's the same. And that's what I want you to do for all 6 of these. Okay? So answer these 6 questions using Desmos, comparing them to the original each time. Once you're done with that, I want you to go here and graph one of these guys. So I'm going to graph this one right now. You can use Desmos to graph this, but once you know how it works, you can use, once you know how the graphing works, you don't need Desmos. So this one here, y equals 3 times the absolute value, x minus 3. X minus 3, right here, it's my first dot. And it goes, that's one side of my absolute value sign. There's the other one. If you graph it on Desmos, you should see the identical thing. How did I do that? Now I'm going to take you to the notes. The notes look like this. And they are right right here. So this note, you're going to fold. You can glue it like this. You don't need this note. You can just write it by yourself in your notebook. But if you have one of these, glue it like this, and here's your information. Okay? There's 1, 2, 3, 4 things on here. I'll explain all 4. Okay. This is my output. Whatever numbers I put in here, the answer, my y value, will be here. This is how high or low I'm going to go every time I put it in a new x. Okay, this number. This tells me my dilation, which means does the graph get wider or narrower based on this number, or does it face up or down? So if it's positive, it faces up. Negative, it faces down. If this number becomes more than 1, it gets stretched up. If this number is less than 1, it gets wider or stretched out. Okay, that's what A does. K, look at K now. K takes a whole graph and just moves it up or moves it down. It's a translation up or down. If it says +3, what it does is goes 1, 2, 3, all done. It slides up 3. Whatever you see, you do. -7, 1, 2, 3, 4, 5, 6, 7, slides down 7. This is the interesting one, my favorite. It's my favorite because it's got a funny story. It has x with h. H is a number that's going to be in there. X will stay x. But if you notice, the h is hanging out with x. Well, this is my story. If x is telling you to -4, remember, x goes this way on the graph, right? If x is saying -4, it means to go that way 4, right? But this is your x talking to you. Do you listen to your x? Now you may, I don't know, this is just part of the joke story. But normally you would do the opposite of what your x tells you. So if your x is saying -4, you're going to go right 4. So this is your horizontal translation, so slide left, right. So if it says +3, you're going to go left 3. If it says -9, you're going to go right 9. That should be with your notes. And that's how I was able to graph that other one without using Desmos. Now, last thing I want you to do is the end of the assignment. Now that you know how the function works, we can take one of these and write the equation. Like, I got a graph, how do I write the equation? Right? Let's zoom it up right there. Okay, I've got my vertex. My vertex, oh, h and k. H is left -1, k is up 2. If you notice from this one, h and k, forgot to put that in there, that makes our vertex. So I'll go back to here. I know that my vertex is negative 1, comma 2. Y equals, f of x equals. What's the slope here? Well, it looks like 1, up 1 over 1, so I know it's 1. My a value is 1, so that's normal. X is there. This one goes to the left, 1. That means I'm going to go plus 1. Do the opposite of what X is telling me. If I'm going to go left, X is telling me right, I went left. It was up 2. That's it. That's how you're going to write the equation based on a graph. And range, we're not going to deal with this much, but basically the range is saying, where are all your y values? Well, all my y values are starting at 2, going up. Y is all the values greater than or equal to 2. If you do that for these other 5 questions, that'd be very good practice. And then try out the word problem at the bottom. Okay?